So previously, we had determined from this equation that we could look at a line that passes through the y-axis at a spot that's called 0, comma b, because x is 0 at that spot, and b is just some number, and passes through some other ordered pair, that we could use x and y values in this statement, which is called the slope-intercept form of a linear equation. And what I need you to remember is the number in front of x is the slope, and the b value, the number at the end, is called the y-intercept. So watch this problem below here, where it passes through the y-intercept of the spot where x is 0 and y is 1. And the slope of that line is 3, which means it's 3 over a positive 1. So remember, if the slope is 3 over a positive 1, that means that its change in the y direction is a positive 3, when the change in the x direction is a positive 1. So if we know this ordered pair is a part of the graph, we could go change in the y direction a positive 3 and change in the x direction a positive 1. Again, we could go up 3 and over 1. Up 3 and over 1, and graph the line that is representative of this intercept right here, and it has that slope of 3. And finally, the name of this equation, if I were to use this mx plus b thing, the name of this equation is y equals, I'll substitute a 3 in for the slope. I'm going to substitute in a 1 because it's the y value. It's the y value on that y-intercept. And then, do you see this ordered pair right here? That ordered pair is x is 1, y is 4. So I'm just going to check x is 1, y is 4 in this equation and see if it checks. And sure enough, it does. So any ordered pair on this line works in this equation, but I was able to start with the y-intercept and use the slope to find several more ordered pairs because I only need 2 points to draw a straight line. But I created 1, 2, 3, I think 4 points to draw that straight line, and that's going to be my goal now. But this document's a little bit crazy here, I'm afraid. I think what I'm going to do, it's number 2, and I'm going to write the problem right over here. And number 2 on your worksheet says the slope is equal to the 2/3, and the y-intercept is a -4 essentially. So I'm going to draw my own graph paper over here so we can see this problem more clearly. So I am going to put tick marks on the y-axis, and if I wanted to graph this line that has this slope and goes through this ordered pair, which is the y-intercept, it will go through the y-axis right there. I always plot that point first, and then I'm going to go in the y direction a positive 2, and in the x direction a positive 3. So my change in y is up 2, and my change in x is to the right 3. Again, my change in y is up 2, and my change in x is to the right 3. And I can not only graph this line, but I could write its name. I'm trying to go through these ordered pairs and not doing the best job. But I could write the name of that line, and the name of that line would be y equals. The 2/3 would go in front of the x, and the -4 would be the y-intercept. Again, this is the b value. It's where it intercepts the y-axis, and this is the slope of the line. So I'm not only trying to graph it, I'm trying to write the equation that goes along with it. Let's see what our next problem is. So number 3 says Find the slope of the line and the y-intercept from the given equation and sketch the graph using the slope and y-intercept. So, can you see that, remember that the number in front of x is your slope. That's the 4/5. And I'm going to grab some different highlighters here. And the constant, when the equation is y all by itself equals something times x and then a number, then that constant is the y-intercept of a positive 2. So I'm going to go to the y-axis and grab that y-intercept, and then the slope is from here to go in the y direction. Remember, the y direction is the change in y over the change in x. So I'm going to go up 1, 2, 3, 4, and then I'm going to go to the right 1, 2, 3, 4, 5, and I can graph that line. So again, up 1, 2, 3, 4, and then to the right 1, 2, 3, 4, 5. And I can graph that line without, here's something I'm going to do. I want to take you back to using a table of values. Another way that we've learned to graph is, for something like this, is we pick values for y and substitute those in. So say we put in a 0 for x in this equation. 4/5 times 0 is nothing, and you add 2 to it and you get 2. Hey, that's the y-intercept, that 0, 2. If I picked a 5 for x, I'd go 4/5 times 5, and 4/5 times 5 gives me 4, and 4 plus 2 gives me 6. Let's go see if I had that ordered pair on this graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Sure enough. So I can graph via a table of values, but it is so much easier to graph in this slope-intercept form. Let's see what the next problem brings. I'm going to wait on this problem, and I'm going to introduce one more problem before we do that one. And that problem's going to be y equals a negative 2/3 x minus 1. So from that, I hope you see that the slope is a negative 2/3 and that the y-intercept is a negative 1. I prefer you to write that as 0, negative 1. So if I were going to graph this line from that data alone, and I think I better stretch this a little bit, I would start with the y-intercept right here at 0, negative 1. And you know how the slope is a negative 2/3? One of these two numbers has to be negative, and one of them has to be positive. It does not matter which one. But if you make the 2 negative, that means in the y direction I should go down 2, and in the x direction I should go to the right, a positive 3. So I'm going to go down 2 and to the right, a positive 3. So down 2 and right 3. If I had chosen to make the 2 positive and the 3 negative from this y-intercept, I could have gone up 2 and to the left 3. So from here, up 2 and to the left 3. That's also going to help me see this negatively sloping line. And I'm now going to connect the ordered pairs. I have graphed it from what's called its slope-intercept form, and I also knew what the slope and the y-intercept are. The last equation in my document is not very clean, so I'm going to go ahead and write it here. The last equation, number 4, looks like this. This is not in y equals mx plus b form. So y has not been solved for. I have some options here. I could get y alone by subtracting 2x from both sides, and I'll have here a 3y. And then I'm going to put the 2x and the 9. I'm going to flip-flop their order. I'm going to put the negative 2x first and then the minus 9. And now I'm going to divide both sides by 3, But here, when you divide both sides by 3, make sure you put the 3 underneath each of these terms because you will not see what's called the slope, which is a negative 2/3. And in this case, the y-intercept, which is a minus 3, which now as I look at this is very similar to the problem I just did a minute ago. So when you go to graph this, you're going to go down 3 for the y-intercept, right there. And then the slope is a negative 2/3, so I'm going to go down 2 and to the right 3. And I only need to do that because 2 points make a line, so I feel awfully confident about my ability to graph and finding those ordered pairs. So I'm just going to go ahead and extend this, and I have graphed the line that was this was in standard form. It was not in slope-intercept form. Lastly, there is another way to do a problem like this, and it's particularly useful when it's in standard form and you can just pick some easy numbers for x and y. For example, an easy number for x would be the number 0. Because if you took 2 times 0 right here, that term would be all gone. So I'm going to look for my eraser and I'm going to pretend to cover that term up. And so on what I have left is 3y equals 9 when this is gone. So I have 3y equals, a negative 9. So if I divide both sides by 3, I found y is equal to a negative 3. This is called the y-intercept. When I let x equal 0 in this very same, when I allow y to equal 0 in this very same equation, this 3 times 0 will be gone. I'm trying to cover it up. And what you have left on the left is just the 2x. So all you have left is the 2x equals a negative 9. And so you divide both sides by 2 and you get x is a negative 4.5. So if we go back to the previous page, x is 0, y is a negative 3. X is a negative 4.5, y is 0. So look at this problem. X is 0, y is a negative 3. And the other one was x was a negative 4.5 and y was 0. So if I try to put my tick marks on here, 1, 2, 3, 4, 5, that's this x-intercept, and this is the y-intercept from this page. So the 0, negative 3, negative 4.5, 0. If you'd like to graph using a different method. I'm an advocate of y equals slope-intercept form, and that's how I will continue.